everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today, I am going to discuss about the concept of definitions and terminology on relational algebra. Relational algebra. So, what is meant by relational algebra and how it is having different types of relational calculus and what are the different types of operations in this session we are going to discuss. So, what is meant by relational algebra? So, it is referred to as a procedural query language. So, in generally, the query language will be divided into two types. Query language will be divided into two types. One is procedural query language, and the second one is non-procedural query language. Non-procedural query language. So, it refers to the procedural query language. So, relational algebra is referred as a procedural query language that takes relational instances as an input and returns relation instances as an output. So it takes input as a relational instance as well as it produces output as a relational instance. So that's why you can say that it is a procedural query language. So it is taken as an input as a relational instances as well as it produces the outputs also as a relational instances. And it can be used to tell the DBMS how to build a new relation from one or more relations in the database. So how to build a new relation, that means that identifies, that establish a relation between two relations. So two relations, that is nothing but relation 1, relation 2. That is nothing but table 1 and table 2. How it establishes the relation between two tables. So it is used to tell the DBMS to how to build the relationship also in between those two relations. The relational calculus. So relational algebra is different. Relational calculus is what? Non-procedural language. Non-procedural, that is nothing but what? We can write the syntaxes but we cannot execute on the system. But in a procedural query language, we can write the syntaxes as well as we can execute on the system. So non-procedural language that can be used to formulate the definition of a relation in terms of one or more database relation. So in terms of what? One or more database relations. So to do this, to formulate the definition relation in terms of one or more database relations, we can have a fundamental operations. We can have a fundamental operations called selection operation, projection operation, union operation, set different operation, Cartesian product operation, and rename operation. So these are all some certain relational algebraic operations performed on one or more relations. So the procedural query language will be executed, non-procedural query language will not be executed. So here relational algebra is a procedural query language. It gives a step-by-step process. To obtain the result of the query. It processes step by step. And it uses operators to perform the queries also. So to execute the queries, we can use this operator. We can use these operators to perform the query evaluations. So without these operators, we cannot execute the queries. So definitely we can use that operators to execute it. From this, what is meant by relational calculus? So relational calculus is a non-procedural query language. So procedural query language is what? We can write a syntax. We can write syntax as well as execute on the system. But non-procedural query language, we can write the syntax but not executed on system. So here, the same way, relational calculus is a non-procedural query language that tells the system what data to be retrieved, but does not tell how to retrieve it. So it shows what data to be retrieved, but it does not shows that how to retrieve the data. So based on that, we can have two types of relational calculus. What? One is tuple relational calculus, TRC. We can call it as what? TRC, tuple relational calculus. And the second one is DRC, that is the domain relational calculus. Domain relation calculus. So one is what? Tuple relational calculus. Second one is what? Domain relational calculus. So tuple relational calculus are nothing but what? Tuple relational calculus are nothing but what? The relations result will be displayed with the help of tuples on basis of tuples. So each and every column in the table is called as what? Tuple. So suppose id, name and age contains in the student table. Suppose we can have id, name, age under the student table. Now each and every ID will be called as tuple, name will be called as tuple, and age will be called as tuple. So based on these tuples, based on this ID, we are going to retrieve the data. Based on the name, we are going to retrieve the data. Based on the age, we are going to retrieve the data. We can tell what data to be retrieved, but how the data can be retrieved is we cannot tell, because of this is a non-procedural query language. So in the same way, the domain relational calculus also. So ID is one tuple, name is one tuple, and age is one tuple. If we have to retrieve the data based on group of tuples, so that is nothing but couple of tuples. Based on the two tuples or based on the multiple tuples, we can go for the retrieval of the data. So that is called as what? Domain relational calculus. That is called as what? Domain relational calculus. The query will be executed based on the tuples, and here the query will be executed based on the domains. So attribute properties will be taken as a domain. Attribute property will be taken as a domain. So here, this is what we are going to see here. Tuple relational calculus is used for what? Selecting those tuples that satisfies the given condition. So here, example taken as a student. So here, the first name is one tuple, last name is one tuple, and the age is also one tuple. So based on this tuple, we can retrieve the data. So here let us write relational calculus queries. Query to display the last name of those students where age is greater than 30. So in generally, we can write this query in procedural way. How we can write? So display the last name. So I want to display the last name. So I can write the query what? Select last name from the table name is what? Student. Where age is greater than. So where age greater than 30. On this condition, I am going to retrieve the data. So this is what I can write the query in procedural language. But in the relational calculus, tuple relational calculus, I can write the tuple what? T dot last name I want to print. And from table what? Table student, T dot student, and age greater than 30. On this condition, I am going to retrieve the data. So the result will be displayed based on the tuple which you want to display. So this is the way we can retrieve the data based on the tuples calculations, In the same way, domain relational calculus. So the domain relational calculus, records are filtered based on the domains. So that is nothing but a group of like first name, comma, last name, comma, age. This will be treated as what? A domain. So in the domain relational calculus, the records are filtered based on the domains. What domain you are going to retrieve the data. So again we take the same table to understand this how DRC works. So first name, last name, age. So where we can retrieve the data from based on the condition. The same way. Suppose I want to retrieve what? Select first name. Select the first name I want to retrieve from student 1 where age greater than 30. So this is the query. I want to retrieve the data based on this query. So what I will print? So those who are having the greater than 30 will be displayed. So that is nothing but only Chaitanya Singh 31 will be displayed. So this is I am going to write in the DRC queries. How can I write? So how can I write? So I am going to write what? So first name comma last name comma age from which table? From the table name is what? Student. Table name is what? Student. And the condition is what? Age greater than 30. And condition is what? Age greater than 30. On this condition, on basis of this domain condition, on this basis of domain condition, I am going to retrieve the data. I am going to retrieve the data. So this is the way we can write the queries in non-procedural form, but we cannot execute as like procedural queries displays. So to do this, different types of operators also use it to perform the query operations. So what are the different types of operators that we are using to perform the queries? So set of operations, set operators. We can have different types of operators: selection, projection, union operator, intersection operator, all these things. But among that all, these set of operators are how it becomes useful. How it becomes useful. So set operations. Set operations. The SQL set operations used to combine the two or more SQL select statements. So this is especially for what? Selecting the combining two or more selecting statements. Selecting statements. So combining two or more selecting statements. So to do this, some operators are like what? Union operator, intersect operator, minus operator, and the exist operator on relations. Relations are nothing but what? Tables. So on this, we can perform union for the two tables. You can perform intersection for two tables. You can perform the minus operation for two tables also. So corresponding to relational algebra, so we can identify it as union symbol, and intersection symbol we can identify it as intersection, and the minus identify as minus, and Cartesian product also we can identify as cross join. So relations participating in the operations must have the same set of attributes. Must have the same set of attributes. So here from this, the first one is what? Union operation. So union operation. So how we can use this union operation to perform queries on two tables. So SQL union operation is used to combine the result of two or more SQL select queries. For combine the result of two or more SQL select queries. The union operation, all the number of data type and columns must be same in both tables on which union operation is being applied. So to perform these set operations, to perform these set operations, what we need to have the constraint. The constraint is what? The two tables must have same columns in the table, along with the same size also. So it should be have same columns as well as it should be have same sizes in the tables. The union operation eliminates the duplicate rows from its result set. So the table 1 contains value is same contains in the table 2 also. Then it eliminates the duplicates. So eliminates them and displays the unique operation. Displays the result as unique result from the two tables. So we can write. How can we write? Query select star from table 1 select star from table 1 union select star from table 2 table 2. So if we want to perform these two operations, what will be the constraints? The tables table 1 and table 2, both T1 and T2 must and should have the same columns, and the size of the columns also. It must be the same. If it is not in the same, then it cannot be exist. The column size could not be in the same size. It will be displayed. So to do these set operators, union operations or set intersection operation, then we must use these two. We must use these constraints, and we can apply the operators. And union all. So union all operation is equal to the union operation almost all, but it returns the set without removing duplicates and sorting the data. So union contains what? It displays the data from two tables excluding duplicates. But union all displays what? Union all displays all the data with the duplicates also. So with the duplicates also it displays both. So here the syntax is what? Select column name from table 1. So select star from table 1 union all select star from table 2. So this is the query 1, this is the query 2. Performing these two queries based on the set operator union all. It displays all the values. It displays all the attribute values, including duplicates also. Next, third one, intersect operator. So intersect operator, it is used to combine two select statements. The intersect operation returns the common rows from both the select statements. So table 1 having some values and table 2 having some values. But from this 1 to 3 values, whatever the common values are subject to this table will be displayed by using this intersect operation. So in this intersect operation, the number of data types and columns must be the same. It has no duplicates, and it arranges the data in ascending order by default. So here syntax is what? Select column name from table 1 intersect select column name from table 2. So in MySQL, intersection operation is replaced with the inner join with a specified condition follows. So inner join conditions are used to perform this intersection operation. Similarly, minus operation. So it combines the result of two select statements. Minus operator is used to display the rows which are present in the first query. So table 1. So suppose table 1 having some values, table 2 having some values. So in this, the minus operator is used to display the rows which are present in the first query but absent in the second query. So those who are absent in the second query will not be displayed. So absenting of the second query will not be displayed. It has no duplicates. Under data arranged. In ascending order by default. So select column name from table 1 minus, we can write it as a select column name from table 1 minus select column name from table 2. So we can write it as select column name, like select star from table 1 minus select star from table 2. Select star from table 1. This is the minus operator, set operator. So in MySQL, it is replaced with the left join condition. So it displays what? Select star from table 1 and join in left join table 2 on table 1 dot column 1 equals to table 1 dot table 2 dot column 1 table 2 dot column 1. So this is the way we can perform the set operators. We can perform the set operators in the relational calculus or relational algebra. So in the relational algebra, selection operator used to selecting the records, projection operator used to projecting the data which you want to display, projecting the data which you want to display. That means what attribute you want to project. So you need to display, you need to select that project of attribute and display the result. Again, set operators are used to perform the queries on two tables with the help of union, all operator, intersection operator, minus operator. And the expressive power of algebra. So for the definition of expressive power of algebra and calculus. So we can have two types of queries. One is safe query and the second one is unsafe query. One is safe query and the second one is unsafe query. So unsafe query is nothing but what? A syntactically correct calculus query that has an infinite number of answers. So unsafe query is nothing but what? A syntactically correct calculus query that has an infinite number of answers. So it may have infinite number of answers. The example, the sailor's table. So example, the sailor's table, which contains if I execute this query based on the different types of queries, we can have the multiple answers. So every query that can be expressed in relational algebra can be expressed as what? Safe query. So writing the queries in relational algebra is taken as an what? A safe query. Writing the queries in non-procedural way, that is called as what? Unsafe queries. So writing the queries in safe query is called as what? Relational algebra queries. And writing unsafe queries will be called as what? Relational calculus. So to do this, what we need to do, relational completeness, is query languages can express every query that is expressible in relational algebra. So that can be expressible in relational algebra. In addition to this, some commercial query languages can express some queries that cannot be expressed in relational algebra also. So that is the way of how we are going to express the power of algebra in calculus. So writing safe queries and writing unsafe queries. So writing safe queries is nothing but what? Relational algebra. Writing unsafe queries in relational calculus is called as the writing of unsafe and safe queries is called as what? Expressive power of algebra and calculus. So how you are going to express the power of algebra queries and calculus queries. So this is all about relational algebraic definitions. So once again we revise the topic which we discussed in this session. So here the first one is what is meant by relational algebra. So relational algebra is nothing but what? We can write the query in two types. One is procedural query and the second one is non-procedural query. One is what? Procedural query and the second one is what? Non-procedural query. So in the procedural query, it takes relational instances as an input and gives output as also relational instance. So it takes and it produces output as a relational instance. So writing procedural query and non-procedural query is simple, but execution part, the procedural query is executed, but not non-procedural query can be executed. So for this, to do this all the operations, to do this all processes, we can have the fundamental operations called selection operation, projection operation, union operation, different operation, Cartesian product operation, and rename operation. So with the help of these all selection, projection, there is all nothing but relational algebra operators or operations. With the help of these, we can write the queries, we can use the queries in both the safe and unsafe queries. So here what is meant by relational calculus? So it is nothing but what? Non-procedural query language. Non-procedural query language that tells the system what data to be retrieved, but It does not tell how to retrieve it. It does not tell how to retrieve it. That means directly it writes the syntax, but it cannot be executed. It cannot be executed. So there are two types of relational calculus. One is tuple relational calculus, and the second one is what? Domain relational calculus. So tuple relational calculus, the relational calculus can be executed on basis of tuples, But in the domain relational calculus, the query will be executed on basis of domains, So tuple is nothing but whatever the result you want to display, you need to put it on the screen. Domain is nothing but whatever the tuples you want to display them in grouping of the tuples is nothing but what? Domain. So to do this all operations, TRC tuple relational calculus and DRC for domain relational calculus. And what are the set operators that are used for performing the operations? So set operators are used to selecting the statements on two tables, but before that it should satisfy the constraints called the same tables. The two tables must have the same type of columns, and same type of column sizes also. Same type of columns as well as same type of column sizes also. So from this, union operation combines the result of two or more selecting statements, but it excludes the duplicates. But union all operators is like as union operator, but it includes the duplicates also. It displays the output on basis of two tables. It includes the duplicates also. And intersection operation, it returns the common values, common rows from the both two tables or both select statements. And here also the data types and the column sizes must be the same. Minus operation, it combines the result of two select statements, but minus operator is used to display the rows which are present in the first query but absent in the second query. So on the left side, what are the values will be there, will be displayed, but in the second table will not be displayed. So to do this, we can use the different concepts called join concepts. We can use different join concepts. So inner join, left join, right join, full order join, Cartesian join, all the different types of joins we are going to use. And last one, expressive power of algebra. So writing safe and unsafe queries in relational algebra is called as what? Expressive power of algebra. So you can express the query in safe way, or you can express the query in procedural way or non-procedural way. So that is the power of algebra and calculus. So this is all about relational calculus, relational algebraic definitions and terminologies on relational calculus and relational algebra. So thank you all.
Like, share and subscribe. Hit the bell icon for more updates.